Every space documentary tells you the same story. Mars, Proxima b, TRAPPIST-1. The same 5 planets, the same hopeful narration, the same conclusion that humanity's future might lie among the stars. But those documentaries are only looking next door. They are showing you the planets that are close, the ones that are easy to talk about, the ones that fit neatly into a 10-minute video. They are not telling you about what's further out, because further out, things get complicated. There are planets in this galaxy that make Earth look like a gray pebble, planets with oceans that make our Pacific look like a puddle, forests that could swallow entire continents, gravity that would reshape your skeleton, and something else. Something that keeps scientists awake at night when they run the probability numbers. The question isn't just, can we live on another planet? The question is, would we even want to? Before we go far, let's deal quickly with the planets everyone talks about. Mars, toxic soil, no magnetic field, radiation death trap. Proxima b, its star fires flares that would strip any atmosphere in geological time. TRAPPIST-1e, tidally locked, one side boiling, one side frozen, no in between. These are the planets space agencies focus on because they're reachable, or at least theoretically reachable within a human timescale. But reachable and livable are two completely different things. So today, we're not talking about what's reachable. We're talking about what's actually out there. The planets that, if we somehow, impossibly arrived at their surface, would present humanity with a completely different set of problems. Not the problem of too little, the problem of too much. 600 light-years from Earth sits a planet that has been quietly sitting in NASA's database since 2011, Kepler 22b. It orbits a star very similar to our Sun. It sits perfectly within the habitable zone. Its year is 290 days. Its star is calm and stable. On paper, Kepler 22b is one of the most Earth-like planets we have found, but here is where it stops being comforting. Kepler 22b is 2.4 times the size of Earth. Scientists estimate its mass could be anywhere between 10 and 35 times Earth's mass. And the leading theory is that it is an ocean world, not a planet with oceans on it, a planet that is an ocean. No continents, no land, no beaches, just water, potentially thousands of kilometers deep, covering the entire surface of a world far larger than ours. The Pacific Ocean on Earth is about 4 kilometers deep on average. The deepest point, the Mariana Trench, reaches 11 kilometers. On Kepler 22b, models suggest the ocean could be hundreds of kilometers deep before you hit anything solid. The pressure would be so extreme that water itself changes state, becoming a form of hot ice that exists because of pressure, not temperature. And then there's gravity. At 2 to 3 times Earth's gravity, your cardiovascular system would struggle to pump blood to your brain. Your spine would compress. Your lungs would labor with every breath. You would survive, for a while, but you would never feel well again. Now comes the question nobody wants to answer out loud. What lives in that ocean? Earth's oceans cover 71% of our planet and contain hundreds of thousands of known species. Most of them we have never even seen. Kepler 22b's ocean covers 100% of the surface, potentially hundreds of kilometers deep, with a geological history that may be longer than Earth's. More time for life to evolve, more space to diversify, more pressure to create forms we have no framework to imagine. If life exists on Kepler 22b, what lives in those depths is not fish. We don't even have a word for what lives down there. 3,000 light-years from Earth, a planet so distant that the light reaching us today left before the first Egyptian pyramid was built. MOA 2007 BLG 192b. This planet was discovered through gravitational microlensing, one of the most precise detection methods astronomers have. And what the data revealed was remarkable. A rocky planet, 3.3 times Earth's mass, orbiting a very dim, very cool star. Because the star is so cool, the planet orbits close enough to remain warm. And because the star is stable, the radiation environment could be surprisingly gentle. But what makes this world extraordinary is one simple consequence of its mass: atmosphere. A planet more massive than Earth can hold on to its atmosphere much more aggressively. The atmospheric pressure on the surface could be several times higher than what we experience here, and a thick atmosphere changes everything. On Earth, forests are limited by temperature, water availability, and carbon dioxide concentration. But imagine a world with more atmosphere, more moisture, more warmth, more carbon dioxide. A world where plants never stop growing. It would not have forests like the Amazon. It would have forests that make the Amazon look like a garden. Picture the densest rainforest you can imagine. Now triple the density, double the height, then add hundreds of millions of extra years of evolution. Every ecological niche filled, every survival strategy refined, every predator perfected. Whatever inhabits a forest world hundreds of millions of evolutionary years ahead of Earth would be beyond our reference point. You wouldn't be an explorer there, you would be prey. And then we arrive at perhaps the most unsettling planet on this list, Kepler 442b, 1,200 light-years away. It scores 0.84 on the Earth Similarity Index. Earth scores 1.0. Mars scores only 0.64. Kepler 442b is one of the most Earth-like planets ever confirmed. But that's not the unsettling part. The unsettling part is that it may be more suitable for life than Earth. Its star is cooler and dimmer than our Sun. That means it burns fuel much slower, potentially surviving for around 30 billion years. Our Sun will last roughly 10 billion years. Earth formed 4.5 billion years ago. We are already past the halfway point. Kepler 442b may have 3 times longer for life to evolve. 3 times longer. Think about what happened on Earth in 4.5 billion years. Single-celled organisms, complex life, forests, dinosaurs, mammals, humans. Now imagine that process running for 13.5 billion years on a world slightly larger than Earth, with more water, more atmosphere, and more stable conditions. What emerges from that timeline is something we cannot model. We know what 4.5 billion years creates. It creates us. We have absolutely no idea what 13.5 billion years creates. But one thing is likely. If life exists on Kepler 442b, it is not behind us on the evolutionary timeline. It may be so far ahead of us that comparison becomes meaningless. We would arrive as colonizers. We would arrive as the least advanced thing on the planet.
Let's talk about something that almost defies description. 420 light-years from Earth, a world called J1407b. In 2012, astronomers noticed something extraordinary. A star was dimming. Not by 1%, not by 5%, by 95%. 95% of the star's light was being blocked. The cause was astonishing. A ring system around J1407b so enormous that if Saturn had rings of the same scale, they would dominate our sky, visible with the naked eye, appearing several times larger than the full moon. The ring system extends 90 million kilometers from the planet's center. For comparison, Earth sits about 150 million kilometers from the Sun. This ring system spans nearly 2/3 of that distance. Within those rings are enormous gaps, signs that moons may be forming, entire worlds being carved out by gravity right now. J1407b is not simply a planet. It is a system of worlds in formation, a place where new celestial bodies may still be being born. Now let's answer the question, can humanity actually live on another planet? Here's the honest answer. The nearby planets, Mars, Proxima b, TRAPPIST-1, are hostile in ways that engineering might someday overcome. Humanity could probably survive on Mars, not thrive, survive. In underground habitats, behind radiation shielding, growing food under artificial light. It would not be a new Earth. It would be an expensive underground city on a dead rock. The distant planets are different. Kepler 22b, MOA 2007 BLG 192b, Kepler 442b. These worlds may possess conditions that are genuinely more suitable for life, in some cases better than Earth, but they are hundreds or thousands of light years away. At humanity's current fastest speed, reaching Kepler 442b would take millions of years. And even if we solved that problem, even if we somehow crossed those distances within a lifetime, we might arrive on worlds that have had billions of additional years for evolution to work. We would not be colonizing those planets. We would be the most fragile organisms on them. The honest answer is simple. There is no planet B that is both reachable and ready for us. The planets that are reachable are not ready. The planets that might be ready cannot be reached. And the truly extraordinary worlds, the ocean worlds, the forest worlds, the ancient worlds, those may already belong to life that has had far longer than us to adapt and survive. I want to leave you with one thought. The famous astrophysicist Carl Sagan once said that Earth is a very small stage in a vast cosmic arena. He was right, but what modern discoveries are beginning to reveal is that the arena may not be empty. It may be filled with stages, some larger than ours, some older than ours, some with stories already unfolding. The question of whether we can live on another planet is really two questions. Can we survive there? And are we welcome? The universe does not appear to have been designed with human comfort in mind. It was designed with something else entirely. And the more we look, the more planets we find that seem to confirm that suspicion. If this unsettled you, good. Subscribe to Void Atlas. We go further every week. And I'll see you next time.